Math Humans. We're going to do 3.1b today. We're going to be continuing our work with probability. Today we're going to talk about complements, probability distributions, and then odds. So the first thing that we're going to talk about is a complement. And notice for those of you that are English nerds that it's PLE and not PLI. PLI means you are pretty. PLE means it is the opposite. I call it the probability of not. So, for example, if you're told that the probability of rain is 47%, then the probability of not, which is the probability of no rain, oops, that's an R, of no rain is going to be 1 minus the 0.47. Remember, it has to be a decimal because this is 100%, and that would be 0.53. So it means that there is a 53% chance of no rain. Okay? So remember that the complement, not, the probability of not, is going to be the opposite. So we call that the probability of E with a line over the top. That is the probability of the complement, which is also the probability of not. And then the probability of E is going to equal 1 minus the probability of the regular event. So notice that if I have a bar over the top, E bar, that's going to be the complement, which is 1 minus the percentage. So let's do some examples. So for example number 1, I'm going to be given a sample space of cards. And so in this particular sample space, I'm going to have my 4 suits: spades, clubs, hearts, and diamonds. Okay, so there's my sample space. I want to know what's the probability of spades. Well, that's pretty easy because there are 4 of those, so it's going to be 1 out of 4. Okay, well then what is the probability of the complement, okay, which would be the probability of not spades, okay? And then in this one, because it is such a small sample space, we could just count. It would be 1, 2, 3. So it would be 3 out of 4. And if we just confirm, our probability of E would be 1 minus 0.25, because this is 0.25, and I would get 0.75, that's a 5, and 0.75 is 3/4. Okay? So for the next example, we're going to be talking about trains. Okay, so we'll do example number 2. Says that a train is going to arrive on time at a station 85% of the time. So the question is, does that mean that the train is late? So the complement would be 1 minus 0.85, which would be 0.15. So does that mean, does the complement mean that the train is late 15% of the time? Well, you can't make that assumption because the train could be late, or the train could be early, E-A-R-L-Y. So we can't make the assumption that if the train is on time 85% of the time, then we could say the probability that the train is late or early, we have to make sure that we include both, is going to be 15%. Okay, so you can't make assumptions when you're talking about probabilities. So we want to go back and remember the number line for probabilities. So remember, this is 0 with 0%. This is a 1, which means it is 100%. And then smack in the middle is 0.50, which is 50%. And remember, that is our equally likely. Okay? This is a sure event. This means that it's never going to happen. So when we talk about probability distributions, very similar to our frequency distribution, it is a list of all possible outcomes and their corresponding probabilities. Whew, lots of words. Alrighty. So for example number 3, we're going to be talking about a probability distribution. So for example 3, we're just going to look at a probability distribution, and we'll do one for a coin for heads or tails because it just makes our chart pretty small, but we get the general idea. So here's our outcome. We could have a heads or we could have a tails, and then our probability is going to be 1 out of 2 and 1 out of 2. So that would be our probability distribution. So sometimes you'll see these with the actual percentage in here. Remember that our probabilities are going to need to add up to be 100%. Okay? So the next example that I want to do, example number 4, is going to be talking about rolling some dice. Okay? So this time, instead of rolling 1 dice, we're going to roll 2 dice. Okay? Or die. I never remember which one is plural and which one is singular, so we're just going to put that down there. So I'm going to show you what happens. I call it a dice chart, and I think when you are managing rolling 2 die, it is easier to do a dice chart. So I'm going to show you my handy-dandy dice chart. So this group of numbers up here would be the numbers that you could get from the first die. These numbers over here would be the numbers from the second die. And then in this particular dice chart, I summed up the 2 numbers. So if I rolled a 1 and a 1, I would get a 2. If I rolled a 1 and a 2, then the sum of the die is 3. Okay, so this is not talking about what's on each number. That would be like the 1 and the 1, the 1 and the 2, the 1 and the 3. So this is talking about the sum of the 2 die. So if I use my dice chart and I wanted to know the probability that the sum is even, okay? If you'll notice, this is a 6 by 6, so there are 36 possible outcomes, okay? So if I look at my even numbers, remember even means that it's going to end in a multiple of 0 or 2. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oops, there's one. I was going to say I missed one. 18. So the probability is 18 out of 36, which is going to be a half. So for the next one, I want to do the probability that the sum, love that epsilon, is less than 7. So this says the probability that the sum is less than 7. So less than 7 means it's not included. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is going to be 15 out of 36, which reduces to be 5 out of 12. Okay? And then for the next one, what if I wanted the probability that the sum was greater than 7? Well, then that means it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So again, it's going to be 15 out of 36 or 5 out of 12. So if you are doing probabilities and you're going to roll 2 dice, I think it's easier to just draw a quick dice chart and then do your probabilities on your dice chart. Okay? So the next thing that we want to talk about, our next kind of topic, is looking at valid probability distributions. So occasionally you're going to be given a probability distribution and then you're going to be asked if it is valid. So let's say here are my outcomes and here are my probabilities, and I had A, B, C, D, and E, okay? And I was told that this one is a half, this one is an 8, and an 8, and an 8, and an 8. So if you add these numbers up in your calculator, then the sum of all of those probabilities is equal to 1, which means 100%. Therefore, this would be a valid distribution. Okay, so then let's look at another situation. So let's say I had an outcome, and then I had, here's my probability, and this is a probability distribution. And again, it's going to be A, B, C, D, E. This one has an F. And I had 0.45, 0.80, negative 0.20, negative 0.35, 0.10, and 0.20. Right off the bat, you should recognize that this has negative numbers. And remember, for our probabilities, that probabilities have to go from 0 to 1, which means this is a non-valid distribution. The interesting thing on this one is if you added up these numbers, if you summed those numbers, they equal 1, but it's still a non-valid distribution because you can't have negative probabilities. The next topic that we want to talk about are odds. And you hear this a lot if you like to gamble. What are the odds? Okay, so there's 2 types of odds. Okay, there are odds for, and there are odds against. Okay, so typically you might see this if you're at a casino or if you are doing racetrack betting or off-track betting or other types of gambling. So we want to know what are the odds for and what are the odds against. So the odds for an event are going to be equal. Odds of the event is going to be equal to the probability of the event divided by the probability of the complement. Okay, so remember, this is the probability of the event divided by the probability of the complement. I'm going to knock my coffee over. Complement, or the probability of not, depending on how you want to remember that. Okay? And then the odds against an event, interestingly, are going to be the odds of the not, and that's going to be the opposite, the probability of the complement divided by the probability of the event. So you need to be really careful when you do your notation, making sure that you're using the right numbers. All right, let's do an example with our odds. So for example number 5, we're going to have a single card, and it's going to be drawn from a deck of cards. We always assumed that the cards have been shuffled, right? Not arranged in order or whatever. So we always assume that they're shuffled. And I want to find the odds Okay, that's what we're looking for. That a card is a red 8. Okay, so before we start, let's go back and remember that there are 2 red suits, and that would be the hearts and the diamonds, and then that would mean that there would be 2 8s. Okay. Ooh, I spelled that wrong. 1T. Okay. All right. So the probability of getting a red 8 is going to be 2 out of 52 because there's 1 in each suit. Okay. So then that's going to be 1 out of 26. So then the probability of not a red 8 is going to be 1 minus the 1 over 26. And I'm going to turn this 1 into a whole number with the same denominator. So I'm going to make it 26 over 26. So I'm going to get 25 over 26. Okay, so then my odds that I'm going to get a red 8 is going to be the probability of the red 8 divided by the probability of not a red 8. Okay, so this is going to be the 1 over 26 divided by the 25 over 26. Okay, and I got to go to another piece of paper. So if you'll remember mathematically, if I have a fraction divided by a fraction, I multiply by the reciprocal. So it's going to be the top number multiplied by the flip of the bottom number. There's 25. The 26's cancel, and so you're going to get 1 out of 25. So the interesting thing about odds is that we never report as a percentage or a decimal. So I would say that the odds of getting a red 8 are going to be either 1 out of 25 or 1 to 25. So that would be the way that we would report that answer. Okay. Our next example, example number 6, says 2 fair die are tossed. Sorry, I really struggle to remember which one's plural and which one's singular. And the sum is recorded. So like our dice chart, okay? And if I have that handy, I might bring that back. Oh, there it is. Okay. Alrighty, and I want to find the odds against, remember that means not, of rolling a sum of 9. Okay, so I'm going to bring back my dice chart, and even though I scribbled all over it, let's look at the 9s. This is a sum of 9, this is a sum of 9, this is a sum of 9, and this is a sum of 9. Okay, so there are my sums. So if I write my math, the probability that the sum is equal to 9 is going to be 4 out of 36, which is 1 out of 9. So then the probability of not a sum of 9 is going to be 1 minus the 1/9. Again, I'm going to make it so I can add these two numbers together. So I'm going to make this 9 over 9, because 9 divided by 9 is 1. And I'm going to get 8 over 9. So remember that the odds against are going to be, forgot the S, the probability of not divided by the probability of yes. Okay? So, and if we wanted to write it officially, it's the probability of E bar divided by the probability of E. My not probability was 8 over 9. My good probability was 1 over 9. So if I do that math, I have a fraction divided by a fraction. So I have, move it up so you can see it, 8 over 9 times 9 over 1. The 9's cancel, and so I get 8. So then I would say the odds against a sum of 9, you always want to say what the number represents, is going to be 8 to 1, or I could say 8 to 1. Okay? Alrighty. So let's say this is our last little bit of information that I want to go the opposite direction. So what if I know the odds and I want to find the probability of an event? Okay, so let's say that the odds are 3 to 5. Okay, so that means that it is 3 times for the yes and 5 times for the no's. Okay. Alrighty. So here's going to be our cool little piece of information. So given the odds, and the odds are going to be A to B, then the probability of an event is equal to A over A plus B, and the probability of E bar is going to be B over A plus B. So I have one last little example for us. Okay. So this is our last example, yay. So then we have a little league baseball team, has odds of 3 to 7 of winning a tournament. Find the probability of winning the tournament. Okay, so as we set up what we know, we have 3 to 7, so that means A is 3 and B is 7. So then the probability of E is A over A plus B. So the probability of winning is going to equal 3 over 3 plus 7, which is 3 over 10, which is 0.3. And then because it is a probability, we can write it as a percent. So it's a 30% chance of winning the tournament. So the probability of winning is going to be 30%. Alrighty, that is it for today. I will see you soon. Thanks for being